Thank you so much for joining us today on Connect and Collaborate, where we come together each day to introduce you to our network of business and community leaders and to discuss the important issues that impact business in Colorado and the region. I'm Tammy Schaefer, your on-air producer, and today we are connecting with the American Council of Engineering Companies of Colorado, and we're focusing on why engineering matters in the water world. And I'm very excited to have a great literal roundtable of guests today. We'll be talking with Cheryl Signs, president of Cheryl Signs Engineering. Cheryl, thanks for being here.
Thank you.
John Sikora, vice president of AECOM. Is that how we say it?
That's correct.
Okay.
Thanks.
Thank you. And Jon George, principal of Bishop Brogden Associates.
Yes, thank you for having me.
Thank you all for being here. Now, I love this conversation with a group of engineers on water and why engineering matters in the water world. Cheryl, do you want to start off and kind of frame it up for us?
Sure. The economic reason for water is really paraphrased by what would you pay for your last drop of water, and that's the necessity of it. So we've developed quite a framework for allocating how you get water, and I wanted to start with the beginning of water in the West, the Southwest, was really the Indians, the Mexicans, who were formed on the Spanish model, who had horrible droughts, and so they adopted a collaborative way of sharing water. And I recommend the Milagro Beanfield War if anybody is interested in that, because it's a really graphic description of, both in a movie and in a book, of how water worked in that Southwest, and how when a corporate raider came in, what was done to kind of shut that down by stealing the water. And so when the settlers came west, who were largely from Western Europe into the eastern United States, they always had water. I mean, they didn't know what waters. Sometimes it was too much, really, you know.
Problematic.
Really. So as they started moving west, they were seeing that it was not the same as they were used to. And there was this saying that was, water follows the plow. The idea was, if you started farming in the West, the water would come. You would have rain and snow, and it would be just like the East. It would be the plow. That didn't work out so well.
Yeah, just to interject there with a couple numbers. I think back east, many places get like 38 inches of rain a year or more. Average here in Denver is 16 inches a year. So just a little over a foot. But that's a big difference between folks back east.
Right. And in the East, they had what they called the riparian water rights, which meant if you lived by a water source, which everybody did, because there were so many water streams, creeks, it was very dense there. The riparian water right is you use it, pass it undiminished in quantity and quality, but everybody had a right to use it. When they got to the western part of the country, nobody lived by a stream except very few. They realized they would have to divert it from the river to be able to make use of it. It wouldn't be like just water wheels and that kind of thing, because they didn't even really have to irrigate, water crops in the East. So they eventually adopted the mining model, which was you claimed your square of land, and this is where your mining claim was. You put your corners up and you went to the official office and claimed it. And water's a little harder to measure than that.
Yeah. And same with mining. It was, if you were the first one there, you got it. And if somebody came later, they couldn't take it away.
Exactly. It's because once you develop an economic reliance on water, you build your farm, your barns, you build your livestock, you have your crops. Most importantly, you have your family. You need to have a predictability about when you're going to get water and how is it going to be used. So that first in time, first in right became the model for how water is allocated in the West.
The prior appropriation system.
Okay.
Right?
Yep, first in time, first in right.
And so the first settler did his economic development. The second settler came and saw what was there already and knew that he would be second in time for the water when it went in short supply, which, as John's emphasized, is pretty frequent in the West. And it wasn't always peaceful, because when your livelihood, I mean your family, is threatened because somebody's taking your water or you don't have enough water, it's a very emotional time. So there were developments that were done so that they could preserve the water and take it from when it's abundant and save it till it was in short supply. And they would do that with later on with reservoirs. But I think the first water right in Colorado was, what was that, John?
Yeah, it was, you go all the way back to 1852 in the San Luis Valley. It's the People's Ditch. So that was the first claimed water right in Colorado. And I mean, people are still claiming water rights today, but we have well over 170 years now of water rights acquisitions.
Right, and in the Denver area on the South Platte River, 1860 is the senior right, but by the time you get to 1865, this is when the settler claimed his water. 1865 is getting to junior. By the time you're 1867, you're marginal on a direct divert from the stream basis. And I think part of the program today is going to be about how stretching out that supply, which comes in June in a big gush of water as the snow melts, how do you save that so you can use it when you really need it in August? And so project development began so that they could stretch the supply from when it was abundant to when they really needed it.
Yeah, so that's definitely where the need for engineers comes in, right?
Very much so. And I just throwing out another thing, Colorado, we're in a very unique, geographic position, as people like to call us a headwater state, such that we really don't have any water flowing into our state from other states. Maybe there's a little creek, but the majority of the water originates here in Colorado as that snowpack. John, you reminded me that roughly 60% of our water falls as snow in the wintertime and comes roaring down the creeks here once runoff starts. But Colorado, being a headwater state, there are actually 19 other states and a country that rely on water from the state of Colorado. So that's a pretty big burden. We provide water to a lot of people.
And Colorado has compacts on how we distribute water, that falls here but is owed to the downstream states.
Right.
And all of the 7 basins in Colorado have different rules on how they operate.
Right, and a compact's an agreement between states that's approved by the federal legislature, but it is some really blood, sweat, and tears have gone into drawing up how water is going to be divided between all the states that rely on the source, which is Colorado. So there's some real interesting history in that too.
For sure.
Yeah.
Because it's not only the local water rights issues. What Cheryl described in most of Colorado is over-appropriated. There's some areas. Go ahead.
Which means there's not enough water to serve all the water rights that have been claimed. Sorry.
But there still are places in Colorado that are under-appropriated. So there's large stretches of the Yampa River where you could go get a water right today. And even the area below Grand Junction on the Colorado River is under-appropriated. So today you could go out, claim your water right and start irrigating.
Oh.
In very specific areas.
Not just anywhere?
Not just anywhere.
So that's a great history of the water rights and just how precious water is, especially in the West. Where can you explain for us from that process of getting the access to the water, how it gets to the tap and these are feats of engineering.
They truly are. And what's interesting is I'm actually helping teach my son's 4th grade class on this very topic right now. And it's kind of interesting on how, most people don't realize how that water gets to your tap and everything that's involved with it, from the water rights and the allocation to the conveyance, on how you move that water from where it exists to where you need it. Sometimes that involves pumps. In the days of the 1800s, it all had to be by gravity. And some of the engineering that went involved in the 1800s to move that water is very impressive, because it had to flow by gravity. They didn't have electricity or some sort of power to move water like we do today.
I'm just going to add one thing there. They did have power, and there were windmills for groundwater. And most people agree that if there weren't windmills, the West would not have developed because they were so critical to supplying the settlers' domestic needs for their in-house water. So they had the wind, but that didn't do much for moving the water you need for irrigation.
Not masses of it.
Right.
The first renewable energy.
Right. Well, and John, as you were describing that, it made me think of, if you're teaching fourth graders, that kind of in the same position of a lot of people out there who as far as they know, food comes from the grocery store and water comes from the tap, right? So there's a lot more to it.
There's a lot more to it. And I'm from Glenwood Springs, and it's kind of interesting to see the dichotomy of people that live on the western slope where water touches most of our aspects of life, from recreation, to drinking water. And more people, I think, are in tune with where the water comes from and why. When you live here in Denver, you're so far removed from where the water comes from that I think the average person
can take it for granted.
They do. They really do.
Well, I worked for the city of Westminster for a while, and people would call up just enraged. Why do I have to pay for water? Because they were from where there weren't water bills. This is way back in the day, but so just the whole fact that there has to be some financial contribution to getting that water really upset some people.
Following on John's statement of, West Slope, they deal with water maybe a little bit more often, just as some of those facts out there that of the state, 80% of our water is on the West Slope. We only have 20% over here on the Front Range. And that's,
where all the people are.
Where all the people are. We have more people. They have more water.
But at the same time, agriculture uses the most amount of water in the state. It was 86% or so.
86% of the water in the state that's used in the state is used by agriculture.
But that's recycled too, right? To a degree.
To a degree, yes. You put the water out onto the fields, and some of that makes it back to the stream system.
And also about that number is that when it gets very dry out, like it looks like it's going to be this year, the agricultural use drops way down because they take fields out of production. And in fact, in Westminster, when it was a really dry year, like in 1954, the farmers just said, it's not even worth us growing a crop this year because there's not going to be enough water. Oh, wow. And so then the city was able to rent that water from the ag people. So that is one thing, that they're much more flexible than a municipal user.
Yeah, try telling half of Denver, you can't. Sorry, guys, you don't have water. That's not going to happen.
Yeah.
We may tell them you can't water your lawn.
Yeah, they may take some watering restrictions, and those definitely help in dry situations. But that's...
And one of the interesting things, I think, is that, this year is a dry year in Colorado. Depending on where you're at, I think some of the areas in the San Luis Valley may be 40% of normal. Here in the South Platte, it's like 90.
It's now down to 70. It's dropping more and more.
And we're about, in the Colorado Basin, we're probably 80% of normal right now as a basin. But most of that water is in the headwaters in the Summit and Grand County. And out on the western portion of the state, it's more like 50%, of normal. So, we have these reservoirs that help us make it through these dry years. The question is next year going to be dry, and the year after that, where, we could see watering restrictions and different things happen because of the lack of supply.
Well, and one of the most astounding examples of that for me is like Lake Powell, and there's two main reservoirs on the Colorado River, and they are like drier than they've ever been. There's
50%.
There's wondering whether they'll ever be able to fill up again, because we were in a pretty benign period for quite a while, and we're kind of seeing what the real world might look like.
And Lake Powell is the bank account for the upper basin states to the lower basin states. So, when we talked about compacts earlier, between the states, the Californias, Arizonas, and Nevadas have the first right of the Colorado River. And the upper basin states need to supply them a certain amount of water every year. And so Lake Powell, we refer to it as our bank account. So right now our bank account's half empty or half full, depending on how you want to think about it.
How you want to look at it.
Right.
Better than it was, though, isn't it?
Well, and I know there's a number of water projects in the works. I believe Aurora is building a reservoir in the works. So what are we doing to, what are the solutions to, if you're saying Lake Powell is half empty, then how are we managing that?
Well, as Cheryl very eloquently started with the water rights aspect. So these senior rights, the reservoirs are senior rights downstream. So they always get what water's there. They get a call on the river. So upstream we build reservoirs to store it in times of plenty to carry over for these dry years. And right now there's quite a bit of reservoir building in Colorado going on. There's Denver Water, Northern, Aurora, or all have major reservoirs that are, in the final design process that have gone through the permitting, and that whole process to finally get to the point where they're ready for construction.
Right, and another tool that we've been developing is called conjunctive use, and that means then in a dry year, you take water from the ground because it's usually always there. And then in wet years or more average years, you use the surface water. So you combine those two supplies to regulate or manage how you can get through dry years and then celebrate when you get to an average or better year by using the surface water, which also relies on the storage like John was describing. And recycling is also coming into the fore. I believe, isn't it Denver Water that's started?
Yeah, Denver Water has a fairly large water recycling plant there at the Metro Wastewater. They use it for non-potable purposes, so it's for watering big parks and things like that, and putting into a couple ditches and things. So but definitely still recycling that water of all that return flows that come back. People are picking those up and continuing to use them. It's always a constant recycling as you go down the stream.
But most people don't realize is that water is also owed to people downstream.
Yeah.
So the reason Denver Water generally gets to reuse their water is it's brought over from the western slope. And so once you bring that water into a new basin, it can be used to extinction.
And that's because people in the new basin never relied on it before. So it's yours to use up unless you're on the Moffat Tunnel system, which they waited a little too long. But if it's the idea about when you change water from one use to another, most of it's all agriculture, and then as municipal and industrial uses buy it up and go to court to get it changed, you can't take more water out of the stream than was taken historically, because in over-appropriated systems, as John described, you'll be hurting somebody, you'll be injuring is the key word.
Right.
And so you can't take more water than was historically used. And that's what a lot of engineering goes into, is going out to talk to the farmer to see how he used his water, getting aerial photographs to see what crops were growing. And we have different basic models about a corn needs this much water and hay needs this much water. And then we calculate how much water was used, we call it historically, when it was used for irrigation, and then how much will be used in the future by a new user shouldn't exceed that amount.
Yeah, and we also talk with, water users that are downstream of, if somebody's upstream doing something with their water, we may be working for a downstream user saying, hey, how is this going to affect us, and how do we make sure that we're protecting our water rights? We may have slightly junior water rights, or we may have a senior right, but we don't want that project upstream taking water away from our rights as well.
Right.
So there's this, many different types of engineering analyses go into that to kind of keep the system running as, they put it together back in the 1800s.
Correct. And engineers on a friendly basis, unlike well, I'm not going to say that, on a friendly basis. If I have a client that's going to court to change their water, I do my calculations, and then other people who think they might be impacted by that, their engineers and I meet and we discuss what I did. They tell me what I think I did, what they think I did wrong, and I'm going, yeah, I see your point. I did do that wrong.
Yeah,
you know?
it's cooperative. It's collaborative.
Yeah, I think that would be a good lead into I think Cheryl has a story of what it kind of used to be like and walking through a cemetery.
Oh, right.
I think that would be a great story to share.
Oh, that's perfect.
Well, I grew up in Hayden, Colorado, which is up in the northwestern part of the state. And my mother, when we were walking through the cemetery one day, she goes, "Now that man, he died over water. That's his grave. And then this other man, he's the one that shot that man. And the one that shot him had told the person who he shot several times, don't take my water. I need my water. I have my family here. I have my crops here. I have my animals here." Well, the man did it again. He goes, "I told you." And he shot him. And then he went in and just turned himself into the telephone office, which was the jail in Hayden at that time, and just waited for the authorities to come. But that's how emotional it was and can be still.
Right, with scarcity.
Yes. When you don't have water, it's pretty hard.
Water's administered by water commissioners in the state, guys that literally drive to every head gate, turn them on and off, in priority. And one of the interesting facts is they used to be the law in the West. So they were armed and
wow,
and carried weapons and kept the peace.
Right,
because I bet that somebody goes to turn on the water on one end. Oh boy, somebody's frustrated, right?
Exactly.
Right.
Wow.
The last reported shooting in Colorado over water was in 1977, and which is really pretty recent.
I was going to say that's more recent than you'd like to think.
Right. But I think we've matured, and now we leave our guns at home and hire engineers and attorneys to take care of the water battles.
Well, and there's, I told you this earlier, there's a phrase I've only heard in Colorado that I never heard before, was that whiskey's for drinking and water's for fighting. So I didn't realize just how dire it was through many years.
Right. My dad was a division engineer who are like the water commissioners. They work for the state. I probably shouldn't share the story, but he said, water's such an accepted vehicle for fighting that if you're messing with somebody's wife, you better watch your water.
That sums it up quite succinctly. I'm talking today with, you just heard from Cheryl Signs. She's president of Cheryl Signs Engineering. I also have Jon George here. He's principal with Bishop Brogden Associates, and John Sikora, VP of AECOM. And I'm so glad to have you all here. We're talking about, the importance and why engineering matters in the water world. And it seems like that sentence could go both ways, doesn't it?
Absolutely.
Definitely.
Very much so.
So coming up, I guess we're going to have Marilen Reimer join us. She is the executive director of ACEC, that is the American Council of Engineering Companies of Colorado, and we'll look more at the development of water projects and the timing and scope of how those are coming around, and then the funding. So, any quick thoughts on that as we wrap up this segment?
Water's getting more expensive.
There's a good point.
Yeah. It's all about location.
It is. And you're making me more and more grateful that we have a well on our property, and I don't worry too much about it. Thank you for listening to Connect and Collaborate. Stick with us as we go to this break. We'll come right back with more here on Connect and Collaborate, the voice of the Colorado Business Roundtable. Thank you so much for staying with us today. We are focusing on a group of engineers here. It's the American Council of Engineering Companies of Colorado. We're really grateful to have you all here, and we're focusing on kind of water rights and why water is so important, or why engineering is so important in the water world. And like I said before, that sentence can go both ways. They're pretty dependent on each other. I have right here, Marilen Reimer is joining us this segment. She's the executive director of the American Council of Engineering Companies of Colorado. We call it ACEC.
Thanks for having us, Tammy.
Oh, happy to have you.
Being here.
And John Sikora from AECOM. AECOM, and Jon George from Bishop Brogden Associates are continuing with us in this segment. So great conversation. We wanted to focus now at the kind of the development of water projects and either what that entails or what the challenges are.
Yeah, one of the things we advise our clients is you have to think long-term in water. So in the earlier session we talked about water rights, and it takes a while to have the concepts, do the engineering, go through water court. And so the next step usually is some sort of concept engineering and then moving into a permitting phase. And in today's world, that permitting phase may take 15 years to accomplish. A lot of the big projects that are ongoing right now have taken that long. And then, the final design and construction. So overall, you're looking at a 20-year project, before, from conceptualization of it to, final construction on a project. And so you think about that in the life or career of an engineer, and you may get to build one project in your life.
Wow.
Yeah, start to finish, it takes quite a bit of time.
Yeah.
It's really amazing.
That's amazing. So what kind of what's underway now? I mean, you talked in the last segment so much of trying to move or distribute that water from one place to another here in the state of Colorado. What's underway?
There's always projects underway. And you hear a lot about it in the news right now of our crumbling infrastructure. And that's what's happening in the water world too, is that, we have a lot of our infrastructure that's 100 years old. We've talked about water rights that are, 1850. But, a lot of our dams and reservoirs are easily in that 50 to 100 year range. And so at the end of their design life. And so there's always, the repair of those, improving the safety of the structures as long as, or in conjunction with the conveyance of those, so how you move water from diverting it off the stream, to the treatment plant and ultimately to the tap. So there's always projects that are out there, but in different phases, of planning and design.
Yeah, and just to throw out a story or an example of one of those projects that I think is maybe some of the folks here in Denver know a fair amount about, and it's closer towards kind of the end of its project, is the Chatfield reallocation project. They are just now actually, that project is, the Corps of Engineers decided that Chatfield Reservoir, which was mainly built as a flood control project back at 60s.
Yeah, okay. That sounds right.
That time frame, they actually overbuilt it. So that there was actually some more storage space in that reservoir that people, the people of Denver and other communities around could use some of that extra storage space that ended up being built there. I believe that kind of came around in the early 80s. And so people had filed water rights on it to put more water into storage in Chatfield Reservoir. Well, they just now kind of got the finalization to actually start building the infrastructure at Chatfield Reservoir, moving some of the facilities that have been built there as part of the state park to allow for that additional storage. So here we are in 2018, 30 plus years since the conceptual piece, conceptualization of that project. But it's finally moving, and people will notice. I mean, if you go out to Chatfield Reservoir, you will see dirt being moved, trees being chopped down, because they need that additional space in the reservoir to allow that water to come in and kind of go up and down in that reservoir. But that's a pretty visual one for the folks here in the metro area.
And I think it's an important one where we've taken existing infrastructure and repurposed that existing infrastructure through new engineering, new techniques that allow you to reevaluate the floods to provide multiple purposes. So looking at flood control and water supply. Because in Colorado, we're feast or famine. We don't like to stay in the middle too often.
Right.
Yeah.
Can you talk about a little of the public involvement of those kind of things, that the public is asked to give feedback as part of the permitting process?
Yeah.
Because I think that's important for the public to know these aren't just done by a group of people.
Bunch of engineers in the back room.
Right.
Yeah.
Or the agencies, the public agencies that are involved in it. There's a lot of public involvement in that
There's
piece.
a tremendous amount. And, the Chatfield allocation project, while I personally haven't been involved with it, I've heard the stories of, while it conceptually from an engineering standpoint, it's a great project, a lot of people like the recreation around Chatfield Reservoir. There's
the natural, the trees, the habitat, stuff like that too is a very important to folks.
Which turned out to be the bigger issues than the engineering ones. And, when I was graduating from college at the University of Illinois, the professor sat us down and he goes, "I'm confident in all of your engineering abilities." He goes, "But I have some bad news for you. In the world out there, engineering's the easy part. The people problems are the hard part."
Right, and they're ones that have to have those good communication skills to be able to convey and listen to what the public or those they're working with want, the challenges they want solved, and how then they're going to solve them. So yes, that's a big component.
And in today's world, the permitting process, there is a lot more in public involvement, in our projects, and it's a good thing. I think that to develop multi-purpose projects as opposed to single-use projects is the way to go. Here in Colorado, we enjoy drinking our water, but we also enjoy recreating on it, be it snowmaking for the ski areas or kayaking, rafting, fishing, or just looking at the water. So both flat water as well as white water.
Right. So as we were talking about the availability of water and kind of the scarcity that was dealt with in the past, and we have it now, more access now. So one of the things, water is cheap now, but it's going to get more expensive?
Yeah, all projects get a lot more expensive. The easy stuff's been done.
Oh.
And, as we conceptualize projects, or our clients conceptualize projects, the good sites for dams and conveyance were taken a long time ago. And so the engineering challenges, for building dams, for the foundation conditions, the reservoir stability conditions are just much more difficult today. So which means a lot more money in construction.
Right. I'd add on to that also the quality of the water is a big deal. All of the good quality water has been taken, well, maybe not fully taken, but depending on your location on a stream system, how often that water's kind of been recycled through the system. The higher up in the mountains you are, the better quality it is. And if you're able to take the water there and bring it into your system, you don't have to worry as much or deal with certain treatment processes or contaminants that, that's very high value water to get it up in the mountains versus say down out on the plains. Just that adds to, if you do have water further out from the mountains, the lesser quality, it adds to the cost of the treatment process and just the additional infrastructure you need there to make that suitable for municipal uses.
Exactly.
And that's all reflected in our taxes and our water bills. And
it is. And in the past, a lot of our projects were funded somewhat maybe through the federal government. The Bureau of Reclamation, Corps of Engineers, the NRCS brought federal dollars into Colorado mainly to help agriculture, originally. And that's a lot of our backbone of our infrastructure. But in today's world, it's more of the water utilities that are facing the burden of developing those projects. It's not coming from the federal government. So that long-term planning and that long-term funding is having to be done more at the local level now.
What about the cost? You mentioned this when we were kind of regrouping during our break a little bit ago. The cost of raw water.
It's all about location.
It's very much all about location. And I go back to that last segment where Cheryl said that somebody had called up at one of her old jobs and said, "What? I have a water bill? I have to pay for this?" Yeah, you have to pay for this out here where it is a little bit more scarce. And, cost of water is, even the last 10, 15 years continues to go up. 10 years ago, you could have, purchasing the raw water from, a couple of different sources of either whether going out and getting water rights and having a reservoir or using an existing system, maybe cost, $5,000 for a standard house. Nowadays, you're looking at, maybe $20,000. just for that
to
kind
get
of
access
to
to
have
water?
to have the right to that water and have it at least get close to you.
Wow.
Right.
And it's not even necessarily to the door. It's like, yes, it's $20,000 and it'll be in our system. It's for you, but you still have to treat it. You still have to transport
Wow.
it. You have to still put it in the pipes and get it all the way to the house. So that's, just a kind of the way things are going. And I don't see that necessarily going back the way it was for sure.
Interesting. And locations, that's what you were saying, is it's definitely where you have to get it because all the obvious spots are taken.
The obvious spots are taken, but it's also a function of the water rights. So the people that came here first filed on that water, and so there may not be a water available where you need it. So you have to move it to where the people are. A perfect example is Summit County. With all the development in Summit County right now, it's very difficult to get water, even though you're at the headwaters of the largest river in Colorado. And so if you're below Green Mountain, so the calling right on the Blue River is Green Mountain Reservoir. So if you're below Green Mountain, it's easy to get water. If you're above Green Mountain, it's more difficult. So you may pay on the order of $60,000 an acre foot for water in Summit County. Downstream for agriculture, you may pay $150,000.
Big difference.
So let's talk a little bit about the timing and scope of developing a water project. You mentioned that you can work on one project your entire career. Wow.
Yeah, and that would get boring. So, it's good to be in consulting and have, working on different projects at, at different times, everything from the rehabilitation to, to developing new water. So, as I said, it can take up to 20 years to build this project. And so a lot of that's not all in engineering or all in permitting. It's in the process that it takes to make these things happen.
Then do things change from the conceptualization of that project to the completion when you've got 20 years in between, that there has to be adjustments on the fly?
Yeah, constantly things are changing. The water rights world is constantly evolving, with, the water court and also with legislation on how that changes, water. And so you're always keeping a pulse on that. You're keeping a pulse on, your permitting process and how that's changing your project. And then, trying to bring it all together at the end, to your original idea, to all the input that you've gotten from the public and the federal review agencies, to, finally building that project out there. It's constantly being shaped.
Go ahead, Marilen.
Well, and with that process, I think it's also, I guess I wanted to kind of touch on how you interact with the public as the process goes on. What kind of structure is going on during that time, conceptually? What kind of ways do you get the word out that they should be involved, and what causes then you to change some things?
There's, I guess the first thing comes with the notice, and as little as 20 years ago, most of that was printed, in the newspaper. Mm-hmm. And in today's world, there's instantaneous communication. I'm working on a project right now in New Mexico, and literally you can read about a public meeting as soon as you walk out the door. Somebody's typing as you're in there, and you've got all sides trying to shape what I just said.
Right, because they've tweeted it, whether they got the article published or not.
Yeah.
Somebody's made statements on it before you're even out of there. Wow.
Yeah, and so some of it's, good, to receive public
Sure.
Public input and to help make your project better. But at the same time, you've got a group of people out there that may be trying to kill it for whatever reason.
Sure, and I imagine you walk out or see a tweet or a post somewhere and think, how did they even get that idea?
Yeah. Yeah, and you say something and go, I didn't say it like that.
Right? Oh boy. So tell us, we're talking about these different water projects. Let's talk about funding first. I was gonna take another tack, but talking about the funding, what are the challenges there?
Money's short. You hear it in the news, for infrastructure. Here in Colorado, we're fortunate that we have the CWCB, Colorado Water Conservation Board, and the Colorado Water Power Authority. And both of them have funds, and they also bond, and they use severance tax. So money that's generated from oil and gas and mining in Colorado, a portion of that comes back to the state, and then a portion of that is used to help develop water projects. So some of the smaller projects in Colorado, when it comes to like irrigation districts and some small communities, they really rely on the CWCB. The bigger agencies, not so much. They self-fund themselves.
Right. I think at least some of the challenges of the bigger agencies funding themselves is, I mean, sometimes even they don't have the $20 million to just even go out and get the water rights right away. I mean, these are projects because it takes so long to develop these projects. If you have to go out and buy the water so that it's ready in 20 years, you may not have the funding quite yet. You're relying on people moving into the district or something like that to fund, to buy up those taps for the houses and the businesses and so on and so forth. But you're always expected to have that available whenever they need it. And so you really have to be forward-looking,
really
not only in your
projecting into the
project,
future.
but your finances.
Wow.
And that's a difficult thing. That's, in some instances the CWCB can help with the loans and things like that, but it's a lot of time it's self-funded, and you have to dig into those kind of the extra pools of money that you may have sitting around to kind of leverage that and
Are there
make it
pools
work.
of extra money sitting around?
Small ones. Very small.
That's
At the end of tributaries or something?
Yeah.
that's why we would encourage the state legislature to look at water infrastructure as an important piece that they also need to fund more than they are.
Right.
I know there's big discussion on transportation funding and new streams for funding, but the state legislature is one that has some of the money that hopefully could go into more water projects, especially as our population is growing as fast as it is. More is going to be needed to help the agencies, big and small, address their water needs. And some of that could come through the state legislature and the action that they take. So.
Wonderful. We've talked about some of these development of water projects and what it takes and how long it takes, and can you give us some examples of maybe the most fun projects or the most memorable that either really made a difference or really stood out?
Yeah, tying our discussion on how things change, I had a client, still have a client, Snowmass Water and Sanitation District, that wanted to build a reservoir, and they went out, they bought the land, and they really did a lot of planning. And then they came to do the engineering. And so they hired us. We went out to drill the site, and I met with the board, and I said, you really don't want to build a dam here? They said, yeah, we do. And I said, no, this is bad foundation conditions. And they said, well, we need to build it here. And oh, by the way, our agreement for this land says we will have the project done in 2 years. And if we don't, we have to pay liquidated damages, which was $300 a day. So pretty significant. And so they said, what's it going to take to build the dam here? I said, well, we have to start today. We have to start excavating. So we literally put together a contract to start excavating for the dam, because we had to remove about 30,000 yards of material, and before we could even start building a dam. And so contractors out working, and the client calls me on a Friday morning and says, John, we have a problem. And I said, what? And he said, we found some bones. And I said, what kind of bones? He said, they're really big. We think they're mammoth.
Oh, wow.
And I said, send me some photos. So he sends them to me, and he goes, what do we do? And I said, I don't know.
No.
And never happened to me before.
It's not my territory. I'm
So,
an engineer.
So I happened to have a friend with the Colorado Geologic Service, and I called him, and I said, who do I talk to? He goes, I don't know. And he said, I was at a party a couple weeks ago, and I met a guy from the Denver Museum of Nature and Science. So I get a hold of this individual, and I send him the photos, and he goes, that's a mammoth. And he said, I'll have a couple of paleontologists up there tomorrow to take a look at it. And I said, and this was going to be a Saturday. And so at 8 o'clock in the morning, I had 3 paleontologists knocking on my door. And we go up to site, and we look at where the animal was, and we pull back the peat, and there's a complete mammoth there at the site. You could see the vertebrae, and you could still see the cartilage, in between the vertebrae. And the paleontologist said, well, just keep this area safe. You can work around it. We'll be up here in the next couple of weeks, and we'll excavate it. And so we moved to another part of the site and started excavating, and we hit some more bones.
Oh, no.
And about day 5 after that, we're moving around trying to avoid the bones till the Denver Museum of Nature and Science showed up. We hit a tooth, and I was holding this tooth, and, my dad was a science teacher, so I know a little bit about, past and ice age animals. And I was like, this tooth is not like the other one. And so we Google on our phones, and sure enough, it was a mastodon tooth. So through the whole project, we unearthed about 5,000 Ice Age bones in about a 2-acre area, which is roughly a football field.
Oh, my.
And there's still another 9 to 10 acres out there of just full of bones.
So this is a good example of engineers then having to work with the public.
Right.
And people,
Yeah.
right? And manage a site of, 100 volunteers, and to go through a whole safety program with them that, because now it's a construction site.
Yeah, it was a construction site. We're trying to excavate these bones. We're trying to preserve science and everything that's going there. Yet we had a deadline of finishing this project or facing $300 a day in damages.
Right. Wow.
And so, there was redesigning the project on the fly, so that they could get their work done and we could still get our work done. Yet, and managing the site safety, it was basically 50 new volunteers every week showing up
Wow.
to help excavate bones and
2 different construction seasons.
Two
Because you had
different-
to start and stop with the winter conditions coming.
right.
And Marilen, I imagine when you just mentioned, that's when you have to work with the public, and I imagine that's where you come in with ACEC a little bit in helping to coordinate efforts between these different engineering firms and design and everything. Tell us about that.
Well, yes, thank you, Tammy. And first of all, ACEC is a business organization for consulting engineering firms. So we have experts like both John's and Cheryl that have the technical expertise and the business acumen. And so they are willing to work with the public, work with public agencies, as we've already talked about, in order to come up with the best solutions. And so I'd like to think that ACEC is like the Colorado Business Roundtable, Connect and Collaborate,
Exactly.
right? That we bring people together and share ideas, best practices on what works, what doesn't work, and try to come up with the best solutions. I also hope, John, you have shared this with your school kids, because we want to feed that talent pool, right,
Exactly.
of engineers. And we also give out $40,000 in scholarship money. So legislation, that's why I mentioned the state legislature.
Right.
That's why we get involved with the advocacy at the state and federal level.
Absolutely. So what you're doing is very important, and we appreciate that you're connected with us at the Colorado Business Roundtable to help all of these business organizations. Thank you so much, Marilen Reimer, Executive Director of ACEC, John Sikora with AECOM, and Jon George, Principal at Bishop Brogden Associates. Thank you all for being here and sharing all this great information with us.
Thank you for having us.
Tammy.
Yeah, it was great. Thank you.
Thank you. And thank you all for listening. Have a great day.